All right, so in this particular video, we're going to talk about collecting data and different ways that we can collect data. We need data, right? If we're going to do any sort of statistical analysis or do anything with statistics, we have to have good data. And we have to have a place, an origin for that data. So without data, we can't perform statistics. But we got to be careful about how we collect that data. If our process for collecting that is not very good, then our data becomes questionable. And so when you start to hear about studies, and you're going to hear about them all the time on the news, in I'd say newspaper, but I stopped myself, through any newsworthy apps or anything like that. Apologize for that noise. Apparently we're doing some work on the school, but you're going to hear about studies all the time. And one of the first things that you need to pay attention to is how was the data collected, right? Good process produces good data. You can make good decisions about a population from a small sample, which is awesome. But a bad process provides bad data, and your conclusions just won't make any sense or can't be valid. So even though you may never have to actually set up a study yourself, you're going to be exposed to studies, especially on the news, or anytime celebrities feel like they know more about things than they actually do, start spouting off studies. So in order to understand a study and to really be able to look at a study and know if the conclusions that are being drawn are valid and make sense, you have to take a look at how the study was designed, how the data was gathered, and make sure that the process was good enough to be somewhat reliable. Okay? So in order to design a study, so the first thing we got to do is identify a variable of interest. What is it that you want to know, right? Do you want to know what proportion of the population drives a pickup truck versus a sedan, right? Do you want to know, on average, how long it takes for someone to do their stats homework? Whatever variable you are interested in, you got to define that first and identify it before you can even think about how to go about collecting the data, okay? Then you got to develop a good plan to collect the data. How are you going to get it? And there's 4 different ways that you can go about getting that data, depending on what you want to measure. And also part of that developing a plan to collect the data is how are you going to sample, right? If you're going to sample, and a lot of times we're going to sample, how are you going to do that? And make sure that the way that we're sampling is a way that is going to give us a good representation of the population. That's the only way a sample can really give us information about a population, is if the sample that we take is a decent representation of the population. Then we collect the data, we perform whatever method we wanted to use to collect the data. To collect it, we're going to actually collect it. Then we're going to describe it, either with our numerical summaries or our graphical displays, those kinds of things. Then we're going to interpret the data and try to make decisions. That's our inferential statistics, right? We're going to make inferences and some conclusions about our population. And we're going to feel good about that as long as we set up our study the right way, sample the right way, and then know how to describe it with our numerical summaries and our graphs and our plots. But at the end of all of that, there's always got to be a time for reflection, right? Could I have gotten some bad data somehow? Was there any part of my study that I need to really sort of make a disclaimer on? Hey, look, this is my data and these are my conclusions, but this is one source that maybe this is the data is saying this because I made this mistake, not because it's actually what it is, right? If I want to know the proportion of the population of Indiana that drives pickup trucks and I'm only sampling from people in rural areas, then obviously that's not going to give me a good I'm not going to have good conclusions about the population of the whole state of Indiana, right? So things like that. You have to sort of, even after your study is done, yes, you're going to do everything you can to eliminate those issues. At the end of the study, you still have to go back and reflect on how you got everything and what the conclusions you made. And is it possible that you made some errors? Okay? One way to collect data is what's called an observational study. And this is just where we observe the population. We just take a look, right? If I want to know what proportion of the state of Indiana drives a pickup truck, then I'm just going to go around and look, right? And just observe how many pickup trucks are out there or, whatever. We're not going to actually change the environment or change the conditions on that sample or on that population. What we're talking about there is a treatment, right? We're not going to impose a treatment on anybody, not a control group or anything like that. We're not going to try to change anything. We're just going to look at some information, right? For example, Parents Magazine, at one point they reported a study that found a positive association between the frequency and severity of heartburn during pregnancy of the mom and how much hair the newborn baby has. And you'll hear this a lot, ladies or guys, when you start to have children, that will come up. It did when my wife was pregnant with both of our girls. Do you have any heartburn? If you do, that means your baby's going to have a head full of hair, whatever. According to the study, about 2/3 of women who reported to have modest to severe heartburn during pregnancy gave birth to babies with full heads of hair, while most of women who didn't have heartburn during pregnancy have babies with little hair. That's an observational study, right? We didn't make these mothers, or Parents Magazine didn't make these mothers have heartburn and see if their kids end up with hair. At the same time, they also didn't go in and give the babies hair while they were in the womb to see if mom was going to develop heartburn or not. So they weren't changing any of the conditions of our population. We were just observing and seeing what happened, right? So if that's true, if heartburn is related to hair that babies have when they're born, can you imagine how much heartburn this mother had? Ooh, mama, that's a lot of hair. Right. Next thing you can do is perform an experiment. So if you did want to, actually give someone, give moms heartburn, or give the babies hair, which you wouldn't do either one of those, obviously. Can't give the babies hair, but anyway, if you're going to actually change the conditions of a population, then you're talking about performing an experiment. An experiment has to have a treatment, right? You're still going to sample the same way you would with an observational study. You're just going to impose a treatment on them. It can be a medicine, or in the idea of a control group. So in a good experiment, you're going to have a control group. You need a group within your experiment that's not getting the medicine or not getting the treatment, but they think they are, right? That's called a placebo. You need a group to compare your treatment to. So a placebo is no treatment, right? Like let's say a new headache medicine. If you want to develop a new headache medicine, then you have this medicine and now you want to test it out, right? So you're going to get a bunch of people together who get headaches and give them the medicine. But some of that group you're going to want to give like a salt pill or just a pill that does not have any medicine in it at all, right? That's called your placebo. In your placebo group or your control group. And you want to make it look, taste, feel, whatever, like your treatment, so that the people that are getting the placebo don't know that they're getting a placebo, right? So check out this video.
people's coordination skills. So how did you design this experiment that was going to show that what people believed could affect their bodies?
Well, the first thing we wanted to find is something that happens in everyday life. And one of the things that people do is they drink coffee and tea that has caffeine in it. People report all kinds of effects. They get jittery, they are able to concentrate better, they become more alert, and some of these effects are clearly effects of caffeine, but I wondered perhaps some of them are also effects of thinking that you've taken caffeine, thinking that you've had a caffeinated beverage. So what would happen to people's ability to respond quickly, to concentrate, if we gave them decaffeinated coffee without them being aware of it?
The idea was to test whether decaffeinated coffee would have the same effect on people's coordination as real caffeine. The performance would be assessed before and after they'd been given the caffeine-free drink. So when a volunteer turned up to do the trial, what would they experience?
First thing that we did was to give people some tests of cognitive abilities and motor skills.
And then what?
We asked people then what they thought would happen to their ability to do these tests.
So it's kind of looking at their expectation of what the coffee's going to do.
That's exactly what it is.
It was then time to bring on what looked like coffee and to make sure no one could tell the difference.
We went through the whole ritual of brewing the coffee. We had a recognized brand of regular coffee, although what was really in it that they didn't know was decaffeinated coffee, placebo coffee, if you will. We had just emptied out the bag of coffee and put in decaffeinated coffee.
And presumably you'd use coffee with a great aroma, so it was completely convincing. That's really what they were getting.
It was very important to be completely convincing. We brewed the coffee, poured them a cup, had them drink it. Then we waited for a period of time, about 15 minutes, to let the coffee go through their system, let the caffeine, which didn't exist, take effect. And then we remeasured their performance on these various tasks.
The activities tested the volunteers' coordination.
It included the ability to concentrate and remember strings of numbers, to follow with their hand a moving target, the ability to react very quickly when a particular stimulus would be shown.
So a kind of a concentration test, an accuracy test, and a speed test.
That's right.
But would it work? Would drinking something with absolutely no caffeine really have the same effect as drinking the real thing? The answer was yes.
In more technical terms, there was a correlation, a significant correlation, between what people believed the effects of coffee would be and what the effects of unknowingly decaffeinated coffee was on their behavior.
So just believing that something's going to make you better can make you better, regardless of whether you actually have any of the thing.
That's exactly what our data suggests.
Huh. So kind of interesting there how placebo effects can be strong. Your mind is a powerful thing, right? So, all right. The next method for collecting data might be a simulation, right? And this is where we're going to use a mathematical model or some sort of physical model to reproduce the conditions of a process, right? Sometimes data collecting just involves a computer and running through a computerized simulation. It allows us to study situations that are maybe expensive or dangerous, and so not having to actually put someone through it, right? If you wanted to study car crashes or whatever, you're not going to actually make someone drive through a car crash, right? So the NFL right now going through helmet designs so that they can reduce concussions, right? You're not going to actually put someone in a helmet and test it that way. So you're going to run through some simulations. It's also a way to save time and money. And simulations are often used to help validate results of a different study as well, right? Something like if you were to perform a study and you found that 50% did one thing while the other half did the other thing, then you can actually set up dice and just roll dice and let 1 through 3 represent result number 1 and 4 through 6 represent result number 2, and start talking about if the results you got were because of random chance, right? Sometimes simulations just use a random chance device. And then the last way to come up with some data is to perform a survey. So while you're not going to change anyone's existing conditions or anything, but you may ask them questions. Just ask them questions, right? Different than an observational study, although a survey is kind of like an observational study. You're eliciting responses, but you might ask them in just a face-to-face interview, send them a survey in the mail, call them on the phone, which always makes people really, really happy. Do a web-based survey. Those happen all the time, right? Polls that are put up on a website happen all the time. But the thing with surveys is you have to be really careful how you write your questions so that you don't introduce any kind of bias in the results, that kind of thing. So, for example, and you guys have done this. You guys have done surveys, right? Every year, the school has us do the Monitoring the Future survey, which measures drug, alcohol, and tobacco use and related attitudes among 8th, 10th, and 12th graders, right? So here are some facts and statistics about youth substance use from the 2012 MTF report. So by doing that survey, we were able to find out that in 2012, we were able to find out that in terms of 2011, that 36% of 12th graders use marijuana, right? That 3.8% had tried or used ecstasy, right? Things like that. And by having that data, you can start driving decisions on how to maybe prevent those acts. And from that data, we were also able to tell that from 1975 to 2012, cigarette and marijuana use has gone down, but we've also found out that marijuana use has overtaken cigarette use among 12th graders, among you guys, right? That was, again, from the MTF survey in 2012, right? So, but just asking questions. And again, you've got to set the questions up to where you're not introducing any kind of bias, okay, which we'll talk about that bias another time. Right? So again, your 4 methods of collecting data. You're going to do either an observational study where you're just watching things. You're going to perform an experiment where you're actually giving a treatment to see if there's a difference in how people behave or respond. You can use a simulation to help model dangerous situations so you don't have to actually do it. And then use a survey where you can just ask questions. Just be careful how you word the questions. Okay? And then a large cartoon here. If I'd known they wanted me to use all this info, I would never have asked for it. So careful. If you start collecting data, then you're going to want to do something with it. So make sure you want to.